Graphs of functions. Definition: let f be a function from the set A to the set B. The graph of the function f is the set of ordered pairs such that A and B, such that A is in A and B is in B. And this is not unlike what we've looked at from early on in grade school when you started graphing functions. This just gives us some formal definition for it and some set builder notation. The graph of a function f from A to B is the subset of A times B, containing the ordered pairs with the second entry equal to the element of the set B assigned by f to the first entry. The graph of a function is the same as the relation from A to B determined by function f. Example: display the graph of the function f of n is equal to 2n plus 1 from integers to integers. And the solution is the ordered pairs of the form n 2n plus 1. Obviously where n is from the domain set of integers. So we could plot a couple of these if we wanted to. We could say the first one, if you put in 0 for n, then in the 2n plus 1 second part of the ordered pair, you would get 1. If you put in 1, then you get 3. If you put in 2, you get 5. And then you can graph that. Typical graph here. So at 0, we have a point 1. Let me do that in red. At 1, we've got the point 3. At 2, we've got 5. And that would be a line going in both directions there. For the next example, we'll say display the graph for f of x equals x squared. And that gives ordered pairs of the form x, f of x, or when you substitute in x, comma, x squared. And if we were to graph this, we could go through the trouble of calculating all of these ordered pairs, or since we're probably pretty familiar with this already, we can say, we can do this in our head. The first point there is 0, 0. The next point over here would be 1, 1. And we would have one on the other side of the axes as well, negative 1, 1. And go 2, 4. And negative 2, 4. Let's see, that point's like somewhere right about there. And you could keep on going and develop this out for all of the additional points.